All right, so let's go ahead and get started. Anybody got any questions up front? It looks like most everyone got logged in successfully, which is good, and sent me emails and answered their extremely complex question for homework. So I just want to remind people that the QA system that you used for homework was in a kind of unusual state where I posted a question before the quarter had even begun to give people a chance to log in early and answer the question and so on. But when you're done, it just kind of sits there and says waiting for a question. So the usual state is where it is now, where if you try to run this, it'll say the QA session has ended, and it'll just come back to a command prompt. And then when I post a question, right, and I'll tell you there's a question out there, and you run this, you'll see the screen that you saw before, where you can type in a question, answer, and submit it, and then it'll go back to waiting for another question. But if you need to get out of a program, right, the best way to do that in general is Control C, right? So hold down the Control button and then hit the C button like cat, and that always gets you out of things cleanly. There's a few situations where Control C is ignored, like inside VI, but in general, that will get you out of a program. All right, and the mail program that you use to send me messages, that's not something that we're going to use a lot of, but once in a while it's useful to get information from you on the Linux server instead of having to fish it out of Outlook. And so we'll use that once in a while, and it looks like most people were able to do that successfully. And mail, if you send a mail message to someone, and then you end, you don't get a lot of feedback. You get an EOT in this case, which means end of transmission. It just basically says the program detected there was no more input, and so presumably it sent the message. One of the things about Linux, it does what it is supposed to do, and it's not surprised when that succeeds, right? If you try to do something like copy one file to another, it will copy it, and you won't get any message back saying, Linux has copied your file, ! It just kind of does its thing. And the assumption is that it's going to work, right? So if you don't get an error message, chances are what you're trying to do has been successful. That's kind of a different mindset from what we might be used to, where we get, confirmations and, lots of extra dialogues we have to go through. If I try to remove all the files in my home directory, it will do it without asking, are you sure you want to do this, right? And if it succeeds, it'll just come back with a command prompt. It really talks to you when it needs to tell you something like some unusual condition has happened. So that takes a little bit of getting used to maybe, but it actually ends up being a pretty comfortable way to work. All right, well let's keep digging into the idea of sort of moving around a Unix environment and getting comfortable. Let's talk a little bit about folders. And I'm going to hop into a different account here. So I'll just go into my test account. And remember, ls is a command that shows you what's in your current directory. ls-l gives you more details. So when you first log in, you have a home directory, and it's got nothing in it that you can see. It's got what are called hidden files, but it's effectively empty. And you can do all of your work in that one directory, and all of the C programs you write, all of the short assignments that you work on, all of the tools that you might develop for yourself can all go in that directory, and you end up with kind of a mess, right? You end up with something like my home directory, where it's got 50 files in there and everything steps on everything else. So start getting in the habit of organizing where you put things in your system. You probably already do this in your regular daily computer, whatever you use for your day-to-day use. But from the beginning of working on the Linux server, I really want you to think about putting things in some kind of organization. For example, I'm in CSE224. I might make a folder called CSE224. So I can create a directory with the make dir command, mkdir, followed by the name of the thing that I want to create. Now if I just say make dir CSE224, if I look, I've got a new thing in here called CSE224. And if I do an ls-l, it'll tell me CSE224, that's a directory. I know that because there's that D in the beginning. And so I can change into that directory. And now if I do an ls, there's nothing in there. Okay, I know I'm in that directory because I can say print my working directory and it tells me /home/test/CSE224. There's also this question of a prompt. Okay, you're in a dialogue with the operating system, with bash in this case. You say something, it says something. You say something, it says something. To tell you that it's your turn to say something, it puts out a prompt. It could be as simple as a $, or it could be more complex, such as your username, the name of the machine you're on, which is always called localhost, and then your current directory. Tilde, which means your home directory, /CSE224. So that kind of lets you know where you are in your hierarchy of files. And if I'm, in my CSE224 directory and I want to start working on homework 2, maybe I'll make a directory called homework 2. And inside homework 2, I'll start doing all of my work. Now there's nothing in here right now, but I might make a main.c. and put some stuff in there. And maybe I'll have a make file with some stuff in there, and maybe I'll have function1.c. Alright, so I'm building up my project and I got 3 files here, right? But I don't see this stuff when I log in. When I log in, I see, files for my other classes, my mailbox, and the place where I put my web pages. And when I want to deal with this class, I go into CSE224, and I can, have a directory for homework 3, a directory for my final project, and when I work on homework 2, I go in there, and there's all my files for homework 2. So it's just an organizational thing, right? Strictly speaking, it's not necessary, but it will really, really make your life a lot easier, particularly when it comes time to turn in projects. Because you're going to use something called Git, and Git is about taking all the files related to a project and putting them in kind of one central place where they can be tracked and maintained and backed up and so on. So if you're not familiar with them, a few commands to keep in mind. mkdir for making a directory, cd for changing into a directory, pwd for printing your current directory. If you say cd without anything, it takes you home. If you say cd directory, it changes your directory to whatever that directory is. ls to show you what's in your current directory. And that's enough to move around pretty efficiently. There's lots of other things we can do. You can push and pop directories if you want to go somewhere else and then come back to where you were. We'll talk about those another time. But, just kind of general moving around the file system and organizing your work. All right, now if you're working on a Unix system that you're using to connect to the Linux server, right? We normally connect using SSH, but I might have a parallel structure in my own system, right? So I'm on my laptop right now. My prompt, by the way, is a number inside square brackets, right? That's what the system uses to tell me it's waiting for input from me, and these are consecutive numbers. So this is my prompt on my home system. This was my prompt when I logged in as test on the Linux server. Suppose I want to transfer files back and forth between the Linux server and my own system. Easy way to do that is with the command sftp. There's, like most things in Unix, there's a lot of ways to do this. And there's scopy, and there's GUIs that you can use. There's WinSCP if you're running Windows, and so on and so forth. SFTP is a tried and true command line based system for moving files between systems. And it's really useful once you get used to it. So sftp test at linux.engrcs.com. And normally it will ask me for a password, except I've got that handshake already set up, so it logs me in automatically. But normally it'll ask you for a password. And this is the prompt from this program, sftp followed by an angle bracket. So it's waiting for me to say something. Well, I can say ls, and it runs that ls command on the remote machine. Okay, this is not what's in my directory. This is what's in the directory when I log into test at linuxengrcs.com. And I can say, let's go down to CSE224 and do an ls, and there's my folders for this course. And I can say, let's go into homework 2 and ls, and there's those functions that I just worked so hard on, and the make file. And if I want to copy those to my current machine, I could say something like get function1.c, and it'll tell me fetching from here, that's the address on the remote machine, to function1.c, that's my address here. And if it's a long file, you'll see this progress number increase. When it reaches 100%, you're done. That's something like your transfer rate, the amount of time it took, and I think probably how many bytes it transferred. I can get out of this with good old Control D, and now if I look, I've got a copy of function 1. And if I want to make changes on that on my own machine and then push that back over to the server, right, I can go back and do my SFTP again. I can change my directory to CSE224 homework 2. That's what's on the Linux server right now. I can say put function1.c, and this time it says uploading function1.c to that remote address. So if I SSH back into the server, go down to CSE224 homework 2, there's my files. Guess what's in function.c? It's my new function that I just pushed over. So this is one way to deal with files on two locations, right? Typically one of those locations is your own laptop desktop system that you might end up doing most of your work on, because the server, you know, sometimes it's slow, you got to have an internet connection to get to it, sometimes it might disconnect you, and so on. It's usually more comfortable working on your own system. But then, you know, if you want to push something over to the server, SFTP will work. SCP is perfectly fine. And you can use SSH with commands after it, and whatever works for you is the best way to go. But that's something that's available, and it's got a manual page, right? There's lots of ways you can invoke it, and there's lots of options you can put on it. And then somewhere in here presumably tells you about the interactive commands. So cd, get and put, and so on. But you can do a lot of Unix commands remotely through SFTP, right? So df, for example, to see how much space you have available, and ls, and you can put switches on ls, and so on and so forth. All right. So that's just something to keep in mind. And I'm doing some command line tricks and not necessarily telling you what's going on. So let's talk about a few of these things. Let me go back into my Linux server, and you notice what I did to get there. I said exclamation mark SSH. All right. My prompt shows me a number inside square brackets. What is the meaning of that number? That number is showing me a history of my commands. Okay? Every time that I do a Unix command, it shows the number of that command, right? These are sequential, and these are in reverse chronological order. And the system remembers up to, it's either 2,000 or 5,000. I think it's 2,000 commands that I've executed. And if I say something like exclamation mark and I put in a number, like exclamation mark 2008, it will repeat this command cat function1.c, which won't work, which it will work because I'm in that directory. If I type exclamation mark followed by the start of a command, it will execute the last command that began with those characters. So since I knew I had just done an SSH, I could get back to that command by just saying exclamation mark SSH. And that goes back and repeats that command. That can be a little bit of a dangerous trick. Okay, if you just wiped out all the files in a directory on purpose, and then you want to recall a command like RCP, but you forgot that the last command you did that started with an R was a remove all files in my directory, you might accidentally pull that command back. So that can be a little tricky, right? And again, you're not going to get warnings. It's just going to silently act. So a perhaps safer way to get back to commands is to use your up arrow and down arrow keys. So on my keyboard, if I just hit the up arrow, it will show me my previous command. And I can keep doing that and work my way back to previous commands. And I can hit the down arrow key to go on in the other direction up to my latest command. And so that's another option. Alright, so we have history. We can say exclamation mark some number. We can say exclamation mark some string of characters. We can do the up arrow and we can do the down arrow. And those are ways to reuse commands that you've already done. Yeah, someone says they don't know if they want their computer to remember 2,000 typos. I can agree with that. It's also feasible to get some help in trying to type a new command. So for example, here's this function function1.c, and I want to VI it. Well, I can edit it, VI function1.c. That's kind of a pain. That encourages me to use very short names for my files, which is not useful for organization. So here's the thing. If I just type the letter F and I hit a tab, the shell will show me every possible reasonable thing that I might have been planning to type. So I type VI space F and I hit a tab, and guess what? It fills in the rest of function1.c for me. Alright, so let me make some more functions. Alright, so now I got 4 files in here. So if I say VI space F and I hit a tab, what's it going to do? It's going to complete as much of the word as it possibly can. Since I'm trying to VI something in my directory, and I wanted it to start with an F, the only thing I must have possibly meant was either function1.c, function2.c, or function3.c. But the shell can't tell which one I mean. So it types in as much as it can, but it leaves me now to say, okay, I have to type in a 1 or a 2 or a 3. So if I hit tab twice, it will show me my possibilities at this point. and I can say, oh yeah, that was function 2 that I wanted. Well, I can just type a 2 and hit a tab, and it will fill in the rest. All right, so we've got a new function, a new function 2.c, so I can say VIN and hit a tab, and it says, oh, you must have meant new function something. And if I want new function.c, I can just type a dot. I could type .c, or I can type a dot and hit a tab, and I'm good to go. Right? And it's not just VI. VI doesn't just work. Auto-completion doesn't work with just VI, right? If I want to cat a file to see what's in there, I can do the same thing. If I want to remove a file, I can do that, and so on and so forth. All right, so this is in the category of things that some combination of this might be useful for you. Maybe not all of it, maybe not any of it, maybe all of it. But keep these things in mind, right? Jot them down on a piece of paper, keep them near your keyboard, and when you're working for a number of hours and you're feeling like, I keep typing the same thing over and over again, what was that way to avoid having to do that, right? Pull some of these out. Nobody really sits down and just memorizes these things. Okay, that's probably not a good use of one's time. But as the need arises, if you try some of these things and see which ones work for you, right? It's kind of a self-selecting process, picking out the tools that that work well for you. All right, so here's VI function 3.c. Maybe I want to make a new function 3.c. I can use my left and right arrows to go forward and back, so I can go back here and I can type in the word new. And if I make mistakes, I can, backspace and correct them. All right, so let's compile something, GCC-O. I want to compile new function 3.c. I want to put the output in an executable called new function 3. I'm going to do something that could be a little tricky, a little risky, but maybe not. I'm just going to say GCC-O new. I'm going to hit my tab. And if I tab complete to new function 3.c, I'm just going to go back and take off that .c. And I'm going to say new function 3.c. And I just typed in, like a 30-character command with, 7 or 8 keystrokes. This won't compile, by the way. All right, so I can fix new function 3. Let's get rid of that. Now I want to recompile. Probably easiest way, just 2 up arrows. I forgot my main program. I want to edit my file again, 2 up arrows. I want to compile again, 2 up arrows. And you find yourself getting into a rhythm, right? So we're looking for rapid development a lot of times. You're trying to get something to work because you're exploring some concept. You want to figure out, how do I do square roots in C? And you want to write some test code to just print out a square root of something. You want to edit, compile, execute. Edit, compile, execute, right? Can't tell you how many times I've sat late at night just doing something, up arrow 3 times, do something, up arrow 3 times, do something, up arrow 3 times, again and again and again. Because it's the same cycle repeating itself. Edit, compile, execute. All right, so there's command line tricks, and there's a lot more stuff you can do. You can do simple things. So there's, I'm editing my new function. I can do editing from the command line on this. In fact, I can turn on an entire VI style editor on my command line so that I can pull up a line and I can use my VI commands to move around and change text and so on and so forth. That was so cool I had to play with it for a while, but I never took a liking to it. So I did that for, several months and then turned it off. But there's lots of options out there. All right. Multiple windows. Again, this works really well if you're doing your development on your own system at home. So I'm going to go into my function that I'm editing. And I'm going to write some more interesting code. Alright, so I can exit the editor and I can compile this and I can execute it and I can go back into the editor and so on. That doesn't take that much effort, but it's a little bit of a pain for me. So I'm using a terminal program called Console, K-O-N-S-O-L-E. But most modern terminal programs have the option to do tabs, okay, just like in your browser. So I could say File and I could create a new tab. I don't like mice. I live by keyboard shortcuts. So if I just hit a Control-T, I get a new tab opened up. And I'm in the same directory that I was in the previous tab. So I can do my compilation in here. Right, and I can compile my program, and it tells me basically that I missed stdio.h. All right, so I can keep this message that I'm seeing here. It tells me I had an error at line 3. Maybe I've got multiple errors and so on. I can shift left arrow to go back to my other window, and I can come in here, change my text, save my function, come back over here, recompile. Hey, it compiled without issue. I can execute it. Oh, something went wrong. It didn't print out a new line when it finished executing. Come back here. Put in my new line. Come over here, recompile. Come over here, re-execute. Now it works. All right, so I'm minimizing how much I'm moving in and out of my programs because that's not really my goal. I'm not interested in exiting and entering the editor again and again. I'm interested in editing my code and compiling it. I've got my editor window open here. I might be at a place in a very long program that I'm interested in working on, and I can switch over here, do my compilation. If I get an error message like line 3, I can go immediately to line 3, and so on and so forth. All right, so let me pick up some questions here. FTP, yeah, put to put a file, get to get a file. There's some discussion about doing this in Windows. Someone said if you're doing the same thing over and over again, that's when it's time to write a bash script, which is an excellent point, and that's part of why we're going to talk about bash scripting pretty soon. Some discussion on the Windows subsystem for Linux, which if you can get it to work and it behaves, that's great. Would you say that's better than the command prompt because I'm using the command prompt? So I mean, using the Windows system, using the Linux system under Windows, you can bring up a bash shell, right, and do things at the command prompt as well. But yeah, being at the command prompt is going to give you the most flexibility in general. And we'll see that again and again this term. Is there a way to split a screen? Yeah, there is. Tilix is a cool little program you can download. It brings up a window like this. But then you can do things like add another window to the right, add a window below, and so on. And there's shortcuts you can set up to do different things in these different windows. But that's a nice way to see multiple windows simultaneously. So that's TILIX. And yeah, I don't think I have that on the server. Yeah, I can put it on there, but I think it uses X Windows, and running X Windows from the server is a little pokey. But another reason to run Linux on your home machine. X11 is not a nightmare. I saw some chatter about this last night, actually, in Discord. Yeah, X11 is a nightmare when you try to get inside it. I'll agree with that. But Linux has worked with a system called X11 for decades. It's the way that GUIs operate and let you do things like, you know, X-Eyes that follows your mouse around. And it's when it goes wrong, it's terrible, right? I actually got locked out of my computer just a few days ago because something went wrong with X11. I did something as root that I shouldn't have. But when it works well, and it's kind of out of the way. But it seems to ebb and flow as far as how terrifying it is. Forwarding, yeah, we'll talk about how to do what's called X11 forwarding later, so that if you want to run something graphical on the server, you can actually do that from your own machine. We'll get into that another time. All right. Other questions so far? We're really just kind of going through a semi-randomly ordered list of things to think about and try and get familiar with. All right, well, let's talk about compilation. So let me hop over to the server again. Alright, so I'm going to make a directory called work, and I'm going to do all of my work in that subdirectory. I just typed in my hello.c in my home directory instead of putting it in a work directory. So what's the command I can use to move this file hello.c into a different directory? Anybody know that? MV, good. MV is short for move. And so I can say move hello.c into work. And now hello.c is no longer in this directory, but if I look at the work directory, it's inside there. Okay, cp is the command for copy. If you copy, it actually makes a copy of the file and puts it in the destination directory, but it leaves the original in place. So it's MV is kind of like a rename. Alright, so question about VirtualBox. So if you have a Windows machine, you run VirtualBox on it, it gives you a Linux environment, you do your development inside there. You can use SFTP, for example, to push things in and out of there. With VirtualBox, you can also set up your drives to be accessible to your underlying system, Windows in your case. So you can have basically a shared drive between your virtual machine and your physical machine. And then you could do something like WinSCP if you want to drag and drop files from your virtual machine to another server. If that makes sense. Alright, so I'm going to go into my work directory here, and there's my hello.c. So, first way to compile a program is just gcc hello.c. Alright, and I get a warning saying that I should have said integer main. I'll go ahead and do that. Just to avoid the warning. Alright, so gcc hello.c, that compiles your program. So let's talk about this. So cat is a program for looking at the contents of a file. So if I say cat hello.c, that shows me my file without having to edit it. So here's the usual design flow. We have a source program, which is something like hello.c. That's the code that humans can read if the human happens to understand C, right? So I can look at this and I know, oh, this is a main program. It's going to print out hello and a new line afterwards, okay? Easy for me to read, impossible for the computer to read, right? The CPU, the underlying hardware, the chip with, a few hundred pins on it, has no idea what to do if I force this into its memory and say, hey, do this for me, okay? This is human code. This is source code. Eventually, this has to get turned into machine code, which is a bunch of ones and zeros. All right. We do this basically by saying GCC, and it turns our source program into machine code. But there's actually a bunch of steps that happen in there. We'll drill into those later on when we talk about makefiles. But mostly we just have to remember what we're doing when we say GCC is we're creating machine code. Okay? And this is something you'll hear me call an executable file. And this is very hard for humans to read, very easy for computers to read. Okay, it's the low-level stuff. It's been pre-digested for the CPU. So it can look at this and it can say, oh, I should, take this letter M and I should send that to the display and so on and so forth. All right. So minimum case, all we have to do is say gcc hello.c, and that'll compile our program. And if I do an ls, what do I see? I see my original program, hello.c. There's a new file, a.out. That's the executable program. And if I say a.out, it executes. And it says hello. And if I edit my program again, and I recompile, and I re-execute, it runs my new version of the code. All right, so if I try to edit a.out, it tells me it's got a bunch of stuff in it that I don't know how to interpret. But executable programs on this Linux system always have the keyword elf sitting in the beginning. Okay, that's a tag to say what kind of file type it is. Here's something that references the C library, things like printf. Here's a reference to the start of my program. And there's other stuff in here, right? Now you don't want to edit this file. Editing this file will make it unusable. Let's just say, let's just put something in the beginning here. And let's try to execute it. Let's see if it works. Oh, that worked. I guess you can execute it. Okay, so I broke it. So now I get my segmentation fault. It says there's something wrong with the program. But, I can recompile it, and it remakes that file, and now I can execute it again. All right, so somebody asked, How good of a compiler is GCC? It's pretty dang good. It's been developed over a long period of time. It's got a lot of options to it that let you control how much you optimize your compiled image and so on and so forth. On the other hand, it's a little bit generic. So depending on how much it's been tailored to your particular underlying hardware, it might be better or not as excellent as it could be. But it's pretty dang efficient. And C is in many ways, it's a way to let people do assembly language level programming without writing assembly language. But it's really designed to sort of let you say, what should the CPU do? And then it writes assembly language and machine language code to do that. Which is why, you know, it can be very error prone. You can do things that will generate segmentation faults. You can make minor typos that have major impacts. And it can be riddled with security risks when you finish your program if you use things like gets, for example, for reading an input. So it's a trade-off. But yeah, GCC is usually a pretty good compilation. All right, so let's see. Yeah, cat is how you look at the contents of a file. Good. All right, so here's the problem. I'm going to make a new program. Which is going to use a loop to print out hello again a few times. And this is called hello2. Alright, so there's my new program hello2. Well, my executable program for hello is gone. Right? If I say a.out, that's what I got from running hello2. If I want to run my hello.c program, I have to compile it again. And now I can run that. Now if I want to run my hello2.c program, I have to compile that again. Right? And the problem with just saying GCC file name is that you always create an executable called a.out. And that's kind of unfortunate if you have a lot of programs that you might want to execute one, execute another, and so on. So we're going to use a switch. So -o is called a switch. This is a lowercase o. And when you say -o, it means whatever I put after this, that should be the name of the executable file. And then I can say hello.c. All right, this is kind of a single thing. When you say -o, it's got to be followed by the name of the file you want to create. And yeah, this is exactly like the -9 we did in the kill command. That was another switch. So here's what I can do. I can say gcc-o hello.c. And now if I say hello, it runs my hello program. I can say gcc-o hello2.c. And now if I say hello2, that's my executable program for hello2.c. And I've got both of these executable programs, hello and hello2. And I can get rid of a.out, and I can still run my two programs that have been compiled by typing in the name of the corresponding executable file. So putting this into your GCC command is saying, go ahead and do this, but instead of calling the output file a.out, call the output file whatever I put in here. All right, this can get you into trouble if you do the following. If you accidentally do something like this, right, what did I just do? I said I want to run the compiler. I want to compile something, and I want the output file, the executable file, to be called hello.c. Right? In other words, I forgot to put in the name of the executable file that I actually wanted. Something like hello. Alright, so that didn't happen to do harm. But here's where you can get into trouble. If I do something like this, so we can do wildcards in Bash. We'll talk about those later on. But let's say I've got a bunch of files and I'm in a rush and I want to compile all of them, and I say gcc star.c and I put in my -o. I just did something really bad. Okay. There's my hello.c. There's my hello2.c. I just destroyed my source code for my hello2.c program. And I did it with one command, which was this. Okay, so what happened when I said gcc-o star.c? Star.c was equivalent to hello2.c, hello.c. So if I do the following, Bash will say, okay, star.c, let's replace this with every file that begins with a C, that ends with a .c, and it came up with the following. And that's the command that it thought I wanted executed. And what did it do? It said, okay, I'm going to compile hello.c. I should put the executable file into something called hello2.c. And the fact that hello2.c already existed didn't bother it. It simply overrode it with the executable version of this. My source code is lost. No way to get it back. Alright, so one way for now to avoid that, if I'm working in a directory, I'm going to make a backup directory. And every now and then, I'm going to do something like this. I'm just going to copy all my C files into my backup. Now if I had done that before I clobbered hello2.c, I would have had an old copy of it sitting in here in my backup directory. I could copy it out of there. There's much better ways to do backups. Primarily something called Git, which we'll get to maybe the end of this week, otherwise the beginning of next week. But this is another example of Unix will do exactly what you tell it to. And if you tell it to do something different from what you meant, it has no way of knowing that. So you need to be a little careful with what you do, but you also want to start getting into backup habits. You want to make sure that you don't lose important stuff. Right, so I've got a bunch of things in here. I want to get rid of all of them. I can say rm-rf star. That got rid of everything, got rid of every subdirectory. It's all gone. But if I had accidentally been in my home directory when I did that, I would have wiped out everything in my home directory and all subdirectories. All my files would be gone. Really, really hard, possibly impossible to get them back. Now you can put switches on RM, so it will ask you if you want to remove files, things like that. But the default behavior is just do exactly what the person tells it to do, and do it silently. So the worst feeling in the world is if you're working as a Unix administrator and you've got root access and you accidentally type this command from the root of the entire system. And almost everybody who has done Unix administration has done that at some point, and it's a horrifying feeling. And it makes you really glad that computers aren't as fast as they might be, because you can Control-C it before it does too much damage, maybe. All right, so I'll leave it there. Let's talk tomorrow about Bash itself and some commands, and start moving towards doing some Bash programming. All right, so I'll see you next time. Thanks.